Okay. So here, if you look at the following diagram, you are given the circle, you are given straight lines. It's not one straight line, you're given straight lines. So the straight lines that we're given here, you have PK. So they can ask you anything about this line. They can ask you to calculate the gradient of this line. They can also ask you to calculate the gradient of this line here. Now, if we go through this, they are telling us which we have this thing here as a diameter. Now, if this is a diameter and then this is a center here, this is very important, guys. This is the center of the circle. Okay? But a line is going to have what? A midpoint. So the first question says you need to calculate the gradient of SR. Come and check. Do you know what is S? Do you know what is R? Come and check the coordinates here. Do you know the coordinates of S? Do you know the coordinates of R? You don't know them. By the way, you could use AMA coordinates waka P and R if you knew what was P and R. You could use AMA coordinates waka P and S if you knew what were the coordinates of P and S. Because these things are collinear, they have exactly the same gradient. So if that one didn't work then, how then do we get this thing here? We're going to use the fact that from Euclidean geometry, we know which a diameter and a line that touches the circle only once. We call this line a tangent. And then we call this one a diameter. A diameter and a tangent, they form a 90-degree with each other where they meet at the point of contact, which is point P here. And then if that's the case, here's what we know. In analytical geometry, this means the M of SR multiplied by the M of PK, they're going to give us what? -1. Now look at this. I know what are the coordinates of P. I also know what are the coordinates of what? I know the coordinates of P. I also know the coordinates of K. Of PK, this is what we get. We get -2. Then we'll come and substitute here and say, but now we know what is the M of PK. Instead of M of PK here, we can put something here. So we have, let's look at the following. We have M of RS multiplied by M of PK. We know what is M of PK. So we're going to say M of PK, we're going to multiply this with -2, which is going to be -1. And then I want M of PK. If you wanted M of PK on its own, what is going to be M of PK here? You want to have M of PK, and then you have a multiplication here. We should be careful here. We don't have an addition here. How do you undo a multiplication? You divide again. So you're going to divide both sides by -2. You divide by -2. And then it says M of RS is going to be equaling to 1/2. Now here's what you have then. You know what is this gradient? The gradient of this line here, you come and say, okay, we know what is M of this RS. The M of RS is going to be 1/2 again. Now, for you to calculate an equation of a line, if you have a gradient and a point, then you can calculate the equation of the line. Then it means you can say, you can use the following, which says y is equaling to mx plus c. Okay? And then you come and say, we know what is m. We'll substitute here and then we say we know what is m. What is our m here? So we'll put 1/2 here. Now we still need to get what is c. Now, how do you get c? You're going to use the point which is on this line, any point which lies on this line. So I can't use s because I don't have, okay? But I can definitely use what? P. According to P, P says which we have x. X is -4, okay? What is y? Then I will put which here I have 5, which is going to be equal to 1/2 multiplied by, what is our x? -4 plus c. And then if you do this, it says which you are going to have 5, which is going to be equal to -2 plus c again. And then it says which c is going to be what? 7. Therefore, it makes the equation. Oh, we're looking for the gradient first. And then the equation of this line, then we got it as, this is number 2, this is number 1. M, it's number 1. And then number 2, it's the equation of RS. Equation of RS is going to be given as 1/2x plus 7. Good. Now, for us to get the equation of the circle, we need to know what is A and B. And then A and B are represented by the center of the circle. We don't know what are the coordinates of M. We're not even going to pretend as if we know them. We don't know them. Now, since we don't know them, we're going to look for them. How do we look for them? We're going to use the midpoint formula. Okay? Now, the midpoint formula says which m is going to be given by x1, x2 all over 2. And it says y1 plus y2 all over 1 all over 2. Then it says which capital letter M. Here you also come and do it alphabetical. Oh, Mara, we've already done it alphabetical here. We'll just come and substitute. So for x1, according to this, it says which we have 0. Okay? Plus minus 4 all over 2. And then what is our y1? Our y1 is -3. -3 plus 5 all over 2. And then what do you get as the coordinate? The 2 is the one that we have -2, okay? And then we have 1. We have -2 and then we have 1. And then now we want to get the equation of the circle. How to get the equation of the circle? We are going to start by saying, okay, we know now what is the center. The center is going to be given as x minus, open bracket, minus 2, close bracket, all squared, plus y minus 1, close bracket, all squared, which is going to be r squared. Then we still want to get to what is going to be r squared. We don't know what is r squared. Okay? Then you can use any of the points. You can use point K or you can use point P. And then if we use point P, for example, it says which you are going to have -4 plus 2 all squared plus 5 minus 1 all squared, which is going to be r squared. And then you come and type this in your calculator, which we know what is our r squared. Our r squared is going to be equivalent to what? To 20. Then it means with our equation is going to say we have x plus 2 all squared plus y minus 1 all squared, which is going to be equivalent to what? To 20.